Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. So, then let's look at next steps. So here, do we need to do anything? I'm not sure. So, what do we have here? We have review approved. Let's see what is approved. We have 1, 2, 3, 4. This one still has a to do. Okay. Guard against null bolt font. Done, he says. I think we can merge this. Display string. Display string. Got null pointer. Got null pointer. Null bolt font pointer. Okay. Squash and merge. All right. Bold font pointer. Okay. Good. Then next, remove obsolete HTTP proxy option. Okay. Add empty line. Do we care for that? Probably not. Okay. Then I think we can merge this. Character length limit, unnecessary allocation. Okay. Then we can merge this. Need to do's? No. Rebase. Merge. Okay. Done. Then next I think I would like to polish a bunch of reviews that I have opened. Starting with this one from the previous session. So here we have complaints from the bot. Let's see. So token equals this. Right. This one should be not equal. Not equal. There we go. Okay. And then what else? Directory listing. Ignored entry stall enumeration. What is that? Continue. Right. That's not correct because it doesn't reach this one here. Right. Right, that would enter an infinite loop. Right. So we need to done. I think what we can do is first we put this here. That's already simpler, and then we do for not done, and then we move this guy. Well, can we move it here? I think so. Yeah. Otherwise, we could also not use a continue here and just make it, it's not ignored. Okay. I think this will work. Why is there 2 levels of indentation here? That's weird. Good. I think that will work. But Maybe the easier change is we do we do this. If not ignored, then do this. Okay. Is that fair? What about this one? This one is similar. Okay. If that is file ignored. Yeah. Okay, I think that will work. But it's a bit unfortunate because everything else does it with early returns except for this one now. We have a refactor in simplify code, string management. Maybe we can add it as a refactor to this guy here, because it already touches it anyway. So how about we do so revert this shit again. This one and this. Okay. And then we say here bool done. And then we do for done da 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 da. Okay. Then we do the same here. Done. For done. Do this. All right. And then we do, do we have more of these? Find next file. Okay, then we go to the other file here and do not done. Item. Well, This one gets a bit unruly here, because we would need to do eta plus plus, and then also put in this one here, and then probably put this here, plus plus eta, and then remove this. Done equals plus plus eta. Plus plus eta. Is that right? Why do we need this done anyway? Can't we just do... Why is this so complicated? Why do we need this done anyway? Can't we just do... while eta is not directory iterator, and then here plus plus eta, and then remove this shit and this, and here the same. Is that right? Eta the default iterator constructor creates an int iterator. I don't know why this needs an explanation. Eta EC. Okay. So how about we do that? It looks a bit simpler. Eta, yeah, creates an int iterator. Yeah. I think this looks right. Let's see if that compiles. Now, can we also simplify this more then? Find next file. Find first, done. Find next file. What? Returns a bool. Can we simplify this to not have this done here? That would be very nice. Done. Done, if not done. Why is it? So the problem is that this guy here and this one, they return different things. And then they compare different things here. Yeah. Well, let me see. Find next file. What does it do? If the function succeeds, the return value is non-zero. If the function fails, the return value is 0 and the contents of LP find file data are indeterminate. And what about yeah, I can't think of another way. I think it's fine here. Yeah. Okay, we can remove. Let's keep that. Yeah. Good. I think that would work. Yeah. Then basically we would make a fix-up commit for this guy. Eta. Good. Then we take these guys, put them here. Now let's run the game once to see if it still works with this change. And I think we should probably also test the other one. What about the... How can we enable the other file system thingy? File system... Oh boy. Who is enabling this? How do we enable this code here? There must be some... There must be some CMake switch for this, no? Or not? CMake. CMake. Oh boy. Um, I don't know. What do we? How do we search for this? I don't know. STD, no. File system, no. Is there no way to enable this? Oh, that sucks. Let me see. Who is anyone creating this? No one is. Is this not hooked up at all? Is this just sitting in here and is never used? Is that right? Maybe. Okay. Well, if it's just theoretical code and no one uses it, then we don't bother, I think. Let's see if this one. Where's Win32? Local file system used. Right, it's here. Yeah. Okay. So it's just this. Okay. Then we can't test it. That's fine. Good. Then ASCII string, Unicode string. That one will go here. Good. Then we do a we go to main and get latest. Okay, rebase, interactive squash, there we go. Right. Okay, that worked beautifully. And then we rename this to specify string loop this and std. Okay, great. Okay, fantastic. Okay, let's push that thing, but let's run the game once before. Actually, we can already push it, it's fine. Maybe while we wait, we can this here. Oh. Okay. We really need a script for this. Doing it by hand every time. It's a bit cumbersome, but I've been saying it multiple times already, and I always do it by hand. Let me ask. Let's do it another time. Because now I'm always halfway through. Might as well just finish the job. Okay, fantastic. Then we push that. Okay, there are compile errors. Well, that sucks. Okay. Well, then we don't push. What is the problem? Oh. It needs to compile again. Okay. Well, that sucks. Good. Looking forward. Let's see what's up here. Recasting. Okay, there was an open question here. What about this one? Okay, this one needs conflict resolving. Okay. Okay, I don't know why it has to compile everything again anew. What happens? Something happened. Okay, now it compiled without error. Interesting. Good. Then let's run it once. See that the game still works. It does. Okay, fantastic. Let's load a mission here. Test level. Okay, looks good. The game runs. Fantastic. Then we can push it. Hopefully the bot will be happy then. Push. All right. Good. Then next, let's rebase this one here. Audio event RTS. But before we do that, let's do a fetch and prune. Fetch and prune, and then we do delete this one. And then we do this one. And then we do a rebase. Then we have a conflict, so we solve that. Oh boy. Oh boy. So we remove this one, okay. We also remove that. And remove that. Okay. Cool. Ref count class. Then here we probably need to do nothing. Yeah, I think that will work. Let's compile it once. Good. Then I think this one is for a bit later. This one we had just pushed. The bot is happy and gave it a full score. Well, that's good. Appears safe to merge. Hopefully. Okay. We did this here. Good. All right. Good. Then. Okay, this one is compiling. Fantastic. Then we take this guy and push it. Rebased and Merge conflicts. Resolved. Okay. Then, so either we could look at this or we look at this one here again, which had a bunch of comments. Let me take a look. So Maula last week did write that he thinks that the math is not correct. This is wrong. The speed is not the dot product. The dot product tells you the difference in direction between the two vectors. Yes, but it also has a magnitude. The dot product has a magnitude. So it tells a bit more than that. If it goes negative, then it means your vectors are going in opposite directions. The speed of a vector is the magnitude of the vector. The speed for 2D is speed, which you can then scale with a constant, which you still need to check the dot product and negate the speed if the dot product is negative. Okay. So there are two tests that we need to do, I think. But how about we put all the different codes next to each other and then we test them somehow side by side? I'm not sure. Okay, so okay, then so Maula is convinced that we need to do this. What do we have here? Amount of diagonal and straight movement is highly map dependent. A two-player game where players start in the corners will have relatively more diagonal movements, therefore the game will be slower than before. Than on a map where players start in the middle, top and bottom. Yeah, but we have to look at averages. Increases the game speed compared to before. I feel like this solution is too crude. Well, what else do you want to do? Do you want to keep the bug or fix it? Such a major hack and has significant impact on how the game feels. Yeah, but that's because the bug is big. Of course, if you have a bad bug and it has a major impact on the game and you fix the bug, it has a major impact on the game because the bug was just grand. So it's not a major hack. Like it's fixing the bug and it's just trying to preserve the average of the speeds. If this solution is considered, it will need extensive testing among the community on different maps. Yeah, of course. Pathfinding uses a grid-based algorithm, therefore most movements are either horizontal, vertical, or diagonal, but rarely any other angle. Grid-based algorithm, most movements. Well, no. No. You can move the passes. There can be any angle. That's not true. So it's a lot of stuff I disagree with here. need to adjust deliveries of transport payloads, yes, and some other movement related properties, yes, but this must be done regardless, yes. Okay, so I think the first thing we do is test. So we take Maula's code here, yeah, let's do that. So let's switch the branch to here. This one. So, what is it? Physics update, right? There we go. So I think we only need to test forward speed 2D because that's the most relevant. The 3D is only used for the missiles. Okay, so retake compatible CSC. Great. Okay, how do we do this? So let's say here this is Xason fix. Then here we say this is EA original mass. Yeah. Then we add here another one. Else. So this is here the Maula code. Maula edition. Yeah. Good. Now the question is, how do we run these things side by side? I think we can use let me see. Get async key state. Whether keys up or down. How to detect if a key was, let's say, if the, let's say, what key do we take? Let's say if the L key was pressed with get async key state. Okay, in C++. Blah, blah, blah. Okay. L, okay. That looks, key L is pressed. Okay, then we just take this guy and then we do, so we add here a static key, let's say mode, I don't know, static int mode 0. So so if this guy is pressed, then plus plus mode. If, let's say, if plus plus mode is 2, then so 0, 0, 1, 0, 1, 2. So if it's larger 2, then mode 0. And then we do switch modes. How do we? How do we print a message? There should be a function message. Message. Oh boy. Message stream. Is it message stream? No. Oh, message. Oh boy. Everything is called message here in this game, apparently. Oh man. I forgot how it's called. Posting a message to see in the game in the top left corner. Oh, what is it called? Oh, it was something about message. Message, something with message. Something with message. It's not message stream, or is it? Nah. Something else. Message. Okay. Oh, I can't remember what it's called. Man. Something with message. Or was it not message? Send message. Maybe that? Nah. Let's search for pointer message. Aha, in-game UI. There we go. Message. I think it's this one. So, let's try this. Oh boy. So case 0. Oh boy. Include in-game UI.h. Game clients. Is it in there? Message no format. EA code 1, 2. Then we have JSON code, Mauler edition. Let's call it dot product hacks. Yeah. Okay. Good. I think that will work. So if we press if we press key L, it should toggle here these things. And then here we do if mode equals 0 or mode equals 1, then we do this. Then we remove this here and this and this. Man, what's up with all this police here? It's the third time we hear police. There must have been something happening here. Probably a stabbing or something. The usual. Yeah. Stabbings. A reoccurring theme now. So, scaling values. So, Yeah, then let's take this here. There we go. Okay. And then we do else. This goes here, else. There we go. So this is the Mauler edition here at the bottom. And then we also have if mode is 0, then we do this. And if mode is, well, else. Well, we don't need an else. Good. Good. Okay, I think that would work. Looks a bit chaotic. That's fine. Maybe make an indent here. Courtesy. Okay. Can also make this whole thing an indent. Okay. Great. Okay, this is looking good. Yeah. Good. So now we should be able to toggle these 3 implementations in the game. 4 forward speed 2D. We don't care about the other one. So we'll leave that as is. Yeah. Okay. Then wait for the compilation. Oh man, there's so many new topics here. Good. Let's launch this sucker. So then we load here test map. Let's get a USA. Let's get a GLA first. No, let's get a USA. Okay, we have a lot of lags here right now because of the parsing, which is not great. That will make the testing a bit more difficult. Yeah. Okay, then let's go to 30 FPS. Okay. Oof. Oof. It's very sensitive. Okay, well, that's not working well. Mm. Mm-hmm. Current state of a key. Single key press was down. Mm. Okay, then let's do that. Was down. Static int static bool. Key toggled. False. Is down. Key down. Key down. Bool is key down. Was key down. Is key down, and this equals not equals this. Was key down is key down. There we go. Will this work? Maybe. So it still doesn't work well. Why not? What did we do wrong? Was down. Is down. Is down. And not was down. Still doesn't. Why does it skip over all of them? Plus plus mode. Huh? Plus plus. Okay, let me put a breakpoint in here. So what happens? Yeah, okay. Oh, we forgot the brakes. Right. Newbie mistake. Let's call this buggy EA code. Yeah? So let's see if that is correct now. Yeah. Okay, that looks correct. Then let's start with the buggy EA code. Yeah. Let's start in with an infantry guy. Take the ranger here. Yeah. Okay, so the guy walks fast diagonally and walks slower in the straight line, right? Yeah, okay, I think that's pretty obvious. Then next, let's do dot product hacks. So now he walks like that and like that. So this looks good. Then let's try the Mauler one. Mauler edition. Looks very much the same. Looks the same, doesn't it? Mm-hmm. Mm-hmm. So the speed looks very similar between these guys. Let me see. So how fast does it move then? Here, can we see? So it returns 0. Is that right? Okay, that's unexpected. There we go. So that must be it. The other one is the Chinook? No, I don't know what that is. Some wheels. Okay, so this one has 0.666. Okay. And then let's check the other one, this one. This one has 0.55. Okay, it is slower. It is slower. Okay, so there is a difference in speed here between these two. I would like to make a test where we speed up. Let me add here const expr float scalar. That's 10. 1.0 f divided by, let's do 20 or 10. I wanted to move fast. Yeah. Let's say a test scalar. Then here we do times test scalar. Same here and here and there and there. Okay. 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 So basically, I would like to see the movement behavior when units take turns. Because last time we tested with high speed, and then we saw that when they take a turn, then they still have the velocity. There's like a little bit of a drag. And I would like to see the original versus the edits. So we have a dozer. Oh shit. It can't drive there. Okay, let's get a worker. Oh boy. Okay. Oh boy. Good. Let's take this guy. So there you see it has this drag, right? When it changes direction, it's probably hard to see it. Maybe we try this. Yeah. So that makes it more clear. So when it changes direction, it has like it has momentum, right? It has momentum. Okay, then let's try the dot product hex, and that has the same behavior. Okay, then let's try the Mauler edition. And that also has this behavior. Okay. Good. So that is consistent. Hmm. 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 Okay, so the physical properties are okay. So that's good. All right, so then it comes down to the speed. The speed. So the question is, how do we... When we have a dozer, we build an airfield. So the plane flies pretty fast. Mhm. But it's really hard to tell whether it flies in a circle or not. Okay, but I think so. This definitely takes this path, right? Let me double check that. Maintain current position hover. Yeah. Yeah. So I think what we should be able to do here is exit the game. Let's open a map where nothing much is going on, like this one. Oh boy. it can't get to the airfield. There we go. Okay, let's stop this guy here. Oh wow. Oh wow. This one also has trouble collecting. So okay, so how about we take a save here. Barren Badlands, plane, circling. All right. So let me see who is circling. Wings. Mm-hmm. Yeah. Well, let's try to eliminate the other guys here. probably want to kill this. Oh boy. Oh boy. Oh boy. How can we kill the dozer? With the raptor. Take a moment. Oh boy. Oh boy. There's trouble attacking. Man. This raptor pilot is drunk. Oh boy. Oh boy. Oh boy. Oh boy. It hit the terrain. Of course it did. Okay, fantastic. So I wanted to get rid of all these units so that we only have one unit that has physics on the map. Right. So this should be the only one now. Let's put a breakpoint here. Yeah. Okay. Then we let it circle here. And we save. Cancel. Okay. Then we exit the game. Then we make this back to 1. And then we add a static average. Let's say average. Let's say total speed. We should probably make it a double. So we say total, say speed sum sums 3. Then we initialize it with 0. And then we do speed samples. And then we make unsigned int. And then we do let's do float final speed equals that. So final speed, then here we say this, else then here we say final speed is that, and here we say that, else that. Okay. So then here we have speed sums mode plus equal final speed, and then speed samples mode plus equal 1, and then we do then we do let's do speed min, speed max. So then we do speed min is min, so this is dBl max, dBl min, okay. All right, and then here we do min speed min final speed, and then we do max. Why is this not working? Let's do std max. This also doesn't work. Min max doesn't work. Why not? Double float. Oh. Return final speed float double max. Okay, and then we also freshly have a averages. Then we do this. We do AVGs mode, and then here we have final speed plus equal. We do std accumulate. No, we don't need to accumulate anything. We just take sums mode divided by speed samples mode. That's it. That will be the averages. Equal. There we go. Okay, so now we have min, max, and average. And then we can compare these results from the circling plane, because that circle, it flies. it also averages out the diagonal speed and the straight lines and so on, right? So hopefully that will give us a reasonable value. Maybe what I should also do is, I don't care. So then I think we also need to launch it with Quick Start so that we do not see a shell map. So this code should not be called until we load into the mission. Yeah. Okay, here we go. So we start with mode 0. And it will start with some nice speed value. Excellent. Good, then we let it circle. Let's have it go a few rounds here. Round, round, round. Okay, then let's switch to this other mode. Let that go a little bit around. And then we do this one. Let that go around. Okay. Then we take a break here. Put a breakpoint. And then let's take a look at these values here. In the debugger. Okay, they look nothing alike. Okay, well, that's not good. So interesting. So what? Okay, that makes no sense. Those values. Maybe my logic is all wrong. Why is this -3? That's really unexpected. So the last one is this one here, mode 3. This is mode 2. This mode 0, mode 2 here. So average speed AVG. Min. Those values make no sense to me. Yeah. Yeah, I'm really curious about why this is hitting so often then. Why is the speed negative so often? Moving in reverse. For some reason it has huge number of negative dots. Negative. Hmm. Maybe final speed moving in reverse. Dot. I'm not quite sure I understand what's going on here with the negative number. Um, hmm. Hmm. This comment seems to be misleading because the unit is not moving in reverse, but this is called. Oh, I just realized that we do need an else here. Okay, let's put a breakpoint here. So what do we have? So they have round about the same sample count now. Let's see the numbers. So averages. This one is 0.6, 1.33, min, max, 6. So to me it looks like this one is faster. Actually, I'm not so sure what I'm looking at here. Yeah, so the question is, how do we prove which numbers are correct? It's not clear to me right now. We probably need to take the absolute speed, right? And not the negative. But then what is this negative for? I don't understand. What do we do with this? Actual speed. What happens if it's negative? I don't know. It's weird. Because this plane is not... The plane is not flying backwards. But still, we enter this branch a lot. So that's unexpected, right? That shouldn't happen. Speed max 8. Speed max is 8. 8 minus 8. 8, yeah. This one is minus. Speed sums. Speed averages. Yeah, right now I don't quite understand why it can have negative speed and why it's not flying backwards then. Like, how does that work? Actual speed. Maybe that's specific for the plane? That it acts like that? Two goal speed. So what happened? Let's put a breakpoint here. Let's see what happens. So now the speed is negative. What do we do now? So actual speed is minus 1.6 for some reason. Goal speed is 1.166 for some reason. Now what? That makes no sense to me. That makes no sense. Apply forces. What? I'm so confused. I'm so confused. Maybe it's because there are multiple callers here. No, it's just this one. Move towards position. Okay, I don't understand why we have this negative thing there. It's weird. Yeah. Raptor. Bird. What the hell? Why is there a bird? Oh, there's a bird on this map. Oh no. Oh, there are birds on the map that mess with our values. Oh my gosh. Okay. Then we need a different map which doesn't have birds. I didn't know that birds are objects that fly around. Let's take the test map here. Here. That one should be. Yeah. Okay. Okay, the dozer. kill the other raptors. Oh boy. Shooting the raptors damages the airfield more than the raptor. How is that possible? Okay, how do we kill these guys here? Man, they're really robust. Looks like we need a Humvee to deal with this shit. Kill the dozer. Kill the Humvee. Great, good. Now we have one raptor. And hopefully that's the only unit on the map. Let's check. Put a breakpoint here. Raptor. 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 Yeah. Okay, this looks consistent now. Fantastic. Then let's do a save. Let's do a new one. Plane circling. Then we do exit game. So 1, 2, Mauler edition. So that should do roundabout. Let's see, samples. Yeah, one has a bit more than the other, but that's fine. Then we do, what do? We do sample watch here. There we go. Okay, so, okay, speed averages look pretty much the same. Speed min looks all the same here. Okay, so min max here we see there's a difference. Yeah, okay, so it looks like they are round about the same. Speed averages. And max averages. Speed averages. So it looks like this one is a bit faster, but that could be because it flew more diagonally. We need to We need to test a bit more accurately. Mm-hmm. So, oh god damn it. Okay, where did the plane start? I didn't see because of the breakpoint. Let's redo it. Mm-hmm. Mm-hmm. Okay, it started round about here, right? So we let it fly, let's say for 3 circles. So there was 2 now. 1 more. And then we toggle. When it reaches here the cursor position. Toggle. Okay, now that's mode number 1. Now we let it circle 3 times, 2 times more. Nice and easy. 1 more round. Okay, and now we toggle. Now it's a molar edition. Very, very scientific what we're doing. So 1, 2, and 3. So there went 3 rounds. Then let's put a breakpoint down here. And so the samples are round about the same, yeah, plus minus 7. And so what do we have? Okay, speed averages. Okay, so the average speed is a little bit faster, actually. Look at that. Average speed is faster. Speed min. Why is that 1.7 here? That's weird. Unexpected. 1.7. Huh. That is unexpected, yeah. Yeah, I don't know why this 1.7 came to be here. It's really odd. Yeah. Maybe from toggling. I don't know. Speed min, speed max. So speed max looks fine. So the max speed is certainly higher here. Speed min is low. A bit low. The average is higher. Yeah, I don't know why this 1.7 is here. Maybe we repeat the test. Maybe when we toggle from one mode to the other, there's some oddity for some reason, but I wouldn't know how that would come to be. 1.76. Now let's do the test again. I want to see if that's reproducible or not. That was round number 1. 2. 3. 1 more round. Molar addition. 1. 2. 3. Put a breakpoint here. Okay. And we have the same here. Again, it shows like a low min value here for some reason. Yeah. Maybe it happens because we come from this buggy circling. And then the velocity... the velocity is lower. That could be... Yeah, I think this is explained because the velocity is lower here. Yeah, maybe that's why, yeah. Yeah. Yeah, I think we can't really trust this here. Sorry. Good. But so I'm wondering. As far as I can tell, the results we get from the dot product code path. So this one here, the result of this is the same as this here, the square and square rooting, same results. But what I find concerning is that these numbers here, the last two here, are lower than this one. I find that interesting. Mm-hmm. Mm-hmm. Why is it lower? Is that a problem or not? It's probably hard for you to read those values here. Maybe let me copy it into a notepad. Then we can make them a bit larger. Like so. Now it's a bit easier to see, right? So the first column is the original EA code. This is the dot product with a fix, and this is the fix with the velocity magnitude square rooted the velocity, and then I think the reason I don't know, that doesn't make sense. I don't know why this is giving the same results. I mean, these values are pretty much the same, but why? I don't know. It's probably equates to the exact same bullshit, I guess. Okay, so why is this faster? We can probably ask. Let me ask. So this is the. This is one of the code paths. Final speeds. The other one is this. Let's remove this here. Okay. Then let's ask ChatGPT about this. explain what the difference between the following math is. Following implementations. The resulting difference between the following implementations, A and B, is A B dot final speed The key difference is what quantity is being measured. Computes a projection of the velocity under the object's facing direction, forward speed, then applies a constant scaling, ignores how well the velocity aligns with the facing direction. It computes the full speed magnitude, then only uses the sign of the projection to decide whether that speed is positive or negative. Simply final speed. V's velocity, unit facing direction. Since D is a unit vector, the dot product is that. The full speed when moving straight forward, 0 when strafing, half speed when moving, negative when moving backward, speed 10, blah blah blah, sign, speed, magnitude. Now the dot product is used only to determine the sign. The magnitude comes from that, which is therefore. So every forwardish movement has the same positive magnitudes, regardless of angle. Due to this huge behavioral change, strafing now reports full speed instead of 0. Shallow forward angles report full speed instead of reduced speed. Practical effect. Implementation A distinguishes between moving forward, moving diagonally, strafing. Implementation B only distinguishes between moving generally forward, moving generally backward. Forward, diagonally, strafing. It no longer knows how much of the movement is actually forward. Okay, I think that's a good explanation. Let me also ask, let's take this one. Then let's ask given the following implementation C, in the following implementation C, which implementation of A and B is is closer to C. I think that's a reasonable question. Implementation C is much closer to A than to B, although it's not identical to either. Yeah. Let's compare them mathematically. A final speed. So the magnitude is B's final speed sine. The angle only affects the sine of the magnitude. Recall speed. Blah blah. A lot of math. Oh, the test scalar. That wasn't supposed to be in there. Magnitude. C exactly matches A here. Velocity. A measures the projection of velocity onto the facing direction. B measures the entire velocity length. C measures the length of the velocity after each component has been scaled by the corresponding direction component. You can think of C as computing the norm after an anisotropic scaling. Structurally, sine determined by dot, B and C. A embeds the sine and dot product himself. Magnitude reduced by facing alignment. Magnitude independent of facing angle, only B. So in terms of the quantity being measured, C is considerably closer to A. Both A and C reduce the reported speed as a facing vector attenuates the velocity components, whereas B always reports full speed magnitude regardless of the movement angle. The main difference is that A uses an L1 style combination after weighting, where C uses an L2 style combination, squared combination. Okay, I think that's a conclusive answer. So it says that this calculation is closer to the original EA one, and this one, yeah, is not. Okay. Let's remove all of this bullshit here. Let's call this EA code fixed. So this is what we call C, A, B. Okay. Good. Then okay, let's do all of this. Okay. It is quite a bit complicated. Here's test code to test EA imp fixed dot product imp test buggy EA code, C, EA code fixed, A, and Molar edition, B. The speed averages can be tested with a plane on an empty map on guard, with a plane in guard mode circling on an empty map, on an otherwise empty map. It reports the following results in a test, in a real test, with a circling raptor. How does it look? Okay, I think we can remove this here and this. Let's remove this. Oh boy. Ugh. Why does it have to break line there? Oh boy. Why does this not work? Because of trailing? Okay. The columns are speed of EA code fixed is outlier, probably triggered when switching from buggy EA code to should give it a different name here. Dot product impl. Let's go with that. Okay. Okay. Ask the ChatGPT to explain the difference between impulse A and B. Hopefully it can show this, but I think it will fall apart. The key difference, oh boy. Yeah, that's not looking good. Well, apart from the mass, well, this one also looks wrong here. Yeah. Oh boy. Oh boy. Maybe, can we maybe share this link here? Impulse A and B, and then how it compares, how they compare to C. A is reported to be closer to C. Stated to what C does. Okay, will this show? Yeah. Okay. Then let's put that comment here. All right. So the only concern that I have right now, so first things first, I think that we should not do this implementation because this one differs more from what it currently does. This one differs more. Yeah. So I think that this one is correct. Yeah. But I'm not sure what to think about this here, that the average speed here is higher than here. So yeah, I don't know what to think about it. Yeah. Good. I think I will take a break here. Has been 2 hours 30. Yeah. Then I wish you a great day or night. Until next time. Goodbye.